More triangle proofs in geometry today. So we are going to start by saying we've done triangle proofs. If you are at this lesson, you should already know that you can prove triangles congruent by using ASA, SAS, AAS, and SSS. So those are the four what I call three-letter theorems for proving triangles congruent. And now we're just going to learn some more stuff that you can build into triangle proofs. So in this opening exercise here, you should be able to prove these triangles congruent. So I'm going to do one of those things where I want you to do A and B by yourself and then look back up and see if you got the same answers I did. So I am going to stay quiet, do this myself, and then you look up and see if you got it right. Go. All right, so what you should have done with your proof is you should have said that the first and the last part of your givens are nice to know, but they don't lead to anything. That middle statement in the given leads to some congruent segments, RT and TU, and then with those and the givens, you end up with an SAS situation. So the triangles are congruent by SAS, and the rigid motion that maps one onto the other would be a reflection over line L. If you set a reflection over T, that is not appropriate. A reflection over T would be a rotation of 180. T is a point. If you want to reflect, you really want to reflect over a line, and it's completely okay to draw on your own line. Now, C says, now that you know TRS is congruent to TUV by SAS criteria, identify the remaining corresponding sides. This is the whole part of this lesson. I've been saying all along that these three-letter theorems are really a shortcut. The way to prove triangles congruent is to show that all three corresponding sides line up and all three corresponding angles line up and that those six corresponding parts are congruent. But then we said if you can't find all six, there are subsets of three that are good enough. The nice thing about the shortcut is once you know that you have, let's say, SAS, there's still one S and two A's left over that we haven't talked about. So now that I know that those things marked in red are congruent, I now know that this is congruent to that. I know that this is congruent to that, and I know that this is congruent to that. In other words, the pieces that I didn't know in the first place now have to be congruent, because if the triangles are congruent, then all their corresponding parts are congruent. And that is what Cpctc is. Cpctc stands for corresponding parts of congruent triangles are congruent. Cpctc stands for corresponding parts of congruent triangles are congruent. What this really means, and I want you to write in the AKA, is if two triangles are congruent, so once you know that two triangles are congruent, then all their corresponding, and what does corresponding means? Corresponding means matching. Parts are congruent. Cpctc. is just a fancy way or an acronym way for saying once you have two congruent triangles, everything about those triangles is congruent. Even if you haven't been told it, now that you know they're congruent, everything lines up. Okay? What's important about this is it says corresponding parts of congruent triangles are congruent. So you need to know that the triangles are congruent before you use Cpctc. So Cpctc only comes after a 3-letter theorem. Okay? So that's Cpctc. All right, so if we go to the next one, we're going to talk about isosceles triangles underneath this umbrella of Cpctc. So let's get there. We're going to show why the base angles of an isosceles triangle are congruent. Isosceles triangles are triangles that have 2 equal sides, and we also said they had 2 equal angles, but like just because we said so, now let's prove that equal sides create those equal angles, okay? So what we're going to do is take this isosceles triangle, I'm going to drop this angle bisector down, okay? And I want to call this AD, okay? It says label the intersection there, yep. So form that as D, and it says, all right, pretend that we are given triangle ABC with AB is congruent to AC. We want to prove that these two things are equal. I don't know that yet, but I want to prove that those two angles are equal without knowing it ahead of time. All right, so our first statement is that it's isosceles with equal sides, and we drew a bisector. So that's given to us. Now I'm going to go through my givens. AB is congruent to AC. That's marked. Check. AD bisects BAC. Okay, so if AD bisects BAC, then those two things need to be equal. So I'm going to call that 1 and 2 and say angle 1 is congruent to angle 2 because a bisector, in this case an angle bisector, creates 2 congruent parts. Okay. And they want me to prove that angle B equals angle C, but I still don't know how I'm going to do that other than just saying, well, it's supposed to be. So you know what I'm going to do? I'm going to say, let's look at these and say, maybe I can think about the triangles. Well, if that side equals that side and that angle equals that angle, you know what? These two triangles share AD. So AD is shared and is therefore congruent to itself by the reflexive property. And if that's true, and I highlight my givens, I have 2 sides and the angle in between. I have an SAS scenario right now. So now I know that triangle ABD is congruent to, now I'm making this triangle statement myself, so I got to make sure I do the order right. So ABD would match up with ACD, and I know those are congruent by SAS. And now that I know that the entire triangle on the left equals the entire triangle on the right, that means B, which comes from the left triangle, and C, which comes from the right triangle, are congruent by Cpctc. In other words, once I got the triangles equal, I now knew about B and C automatically because those were parts of the congruent triangles that I had no other way of getting to, but now I do. And then it says step 3, identify all the corresponding parts. Okay, so let's see. All the corresponding congruent sides and angles. Well, we've got the ones we already marked. We did B and C, and the other matching ones would be like 3 and 4. And then the other one that we hadn't marked yet would be BD and DC. Okay. And then step 4 says, based on the corresponding congruencies that were formed when the angle bisector intersected BC, what does this mean about the angle bisector of the vertex of any isosceles triangle? So what this is really getting at is because we did this within a certain isosceles triangle, it's going to work for all the isosceles triangle. So the angle bisector always creates 2 congruent triangles. Okay, and there's more I could say there, but that's all I want to say right now. Okay, now that we prove that, we don't ever need to go back and reprove it again. Now we can use all the properties of isosceles triangles within our proof. So if a triangle is isosceles, then the two legs are congruent and the two base angles are congruent. If they say the word isosceles, then you can say those other things. If they never use the word isosceles, but they did tell you that two sides of two sides of a triangle are congruent, once you notice that two sides are congruent within one single triangle, you know it's isosceles, which means also the two base angles would have to be equal. And vice versa, if they told you about the two angles, then the two sides, which would really be called the legs, are congruent. Okay, now we can use that in a proof. This makes more sense in a proof, so let's just come down here. So it says given RST is isosceles. Okay, so RST, the big outside triangle, is isosceles, and R is the vertex. And they're telling me SY equals TZ. Prove that RSY, so prove that this triangle right here is congruent to RZT. Sorry about that, I had to pause there. So RST is isosceles with R as a vertex, SY equals TZ, prove that the triangles are congruent. Okay, well, RST is isosceles, fine, this was all given. All right, now let's go through the givens one at a time. RST is isosceles with R the vertex. Okay, so if R is the vertex and it's isosceles, I know that these are the legs and they have to be congruent. RS is congruent to RT because legs of an isosceles triangle are congruent. And not only that, but base angles of an isosceles triangle are congruent as well. So angle S is congruent to angle T because base angles of an isosceles triangle are congruent. Okay, so I took care of that. And now SY equals TZ. So let me mark that as well. SY equals TZ. Got it. Oh, and you know what? Look at that. I have a side, an angle, and another side. And over here I have SAS also. Sweet. There's an SAS, so I know that triangle RSY is congruent to triangle RTZ by SAS. And if you're wondering, wait, but there's a fifth one, we just give you extra lines in case you go further, because sometimes there are things that you can say that you might not need to say, and we just give you space. Sweet. All right, let's put it all together. Everything all at once. Isosceles and Cpctc. Let's do it all in one. So given triangle JKL is isosceles, fine. KX equals LY, fine. Prove that JX equals JY. Now, this unit is a triangle proof unit. And if your proof statement doesn't say triangle equals triangle and says instead angle equals angle or side equals side, what you need to know is that this means you are eventually going to use Cpctc last, and then your penultimate step, it's one of my favorite words, is to prove triangle equals triangle. Penultimate means second to last, if you didn't know that. Fun word. Okay, so when you see prove side equals side, chances are the easiest way to get there is to say, you know what, I don't know how to get those sides equal, but if I can get the triangles equal, the sides will be equal through Cpctc, and that's a way to kind of start your plan. All right. All right, so they recopied our givens for us, so I don't need to rewrite those. Awesome. And it says JKL is isosceles. Okay. So the big outside triangle is isosceles. That's fine. Let's use what I can from that. Well, if that's isosceles, JK equals JL, pardon me. And that's because isosceles, ISOSCELES, triangles have congruent legs. And then the base angles have to be equal. Angle K is congruent to angle L because isosceles triangles have congruent base angles. Okay. And then they told us kx equals ly. Wow, this is a lot like that last one, huh? So those have to be equal. Fine. Kx equals ly. Oh, but that was given. I don't even need to write it. Oh, and look at that. I have SAS. So while I'm here, I might as well say, you know what? These triangles now have to be congruent because I have SAS. So that tiny triangle I could call JKX. And if I call that one JKX, the other one would have to be JLY. And this is another SAS situation. Now, that wasn't what they wanted me to prove, though. They wanted me to prove that JX equals JY. And I didn't know anything about these, but I do now. Because now that I know the triangles are equal, I know that those remaining sides would have to be equal. So JX has to be congruent to JY by Cpctc. Okay, which again, Cpctc is really an acronym way of saying since the triangles are equal, all their corresponding other parts are equal too. Done. All right, so answer some checkpoint questions and then do these practice problems here. We gave you some of the statements and reasons in these, and you're going to fill out the rest. I hope everybody is having a glorious day. I will talk with you all again later.